I'm Matt Zumwalt, I'm at Work at Protocol Labs, program manager for IPFS and libp2p and the ecosystem around them. This is a talk that I gave at the DWeb Summit where I was asked to present about governance challenges we've faced with IPFS. And so when I was asked to do this talk, I decided to break it down into 4 parts, where the first 2 parts are the governance issues that we've gotten, I think, the most questions about, we most often are asked about, and they actually have to do with governing of the content on the network of IPFS. And then I'll talk a bit about how we are approaching governing the protocols and specifications and code and community around our open source projects. And then I also want to spend some time talking about the questions that some people are asking, but I think everyone should be asking around governance of these protocols. So to begin with, the thing we probably get the most questions about has to do with the dynamics between protecting free speech versus preventing harm. Or you could say it's about both sides of censorship. It's about allowing people to overcome censorship in some cases, and it's about providing the ability to censor in other cases. This is probably the most frequent question that we get. And so the way IPFS handles this dynamic is the way we think about it is that IPFS enables you to make empowered decisions about what data you will possess on your machines and what data you will participate in redistributing on the network. And so you're able to make empowered decisions about how you will participate in these flows and how data will flow in the networks that you are part of. So this is the big shift, that when we switch to a peer-to-peer context, we are all peers who all have the power to have one part of a voice in deciding how information will flow, rather than it being a centralized system. And so the way to think about this intuitively is in terms of how rumors move in social worlds. So there might be a rumor moving around that you're happy to repeat. It might be great news that you're wanting to pass around. In other cases, there might be a rumor that you decline to repeat. Even if you're asked about it, you're not going to repeat that information. And then there might be other information that if you see other people repeating it, you're going to go out of your way to say, hey, that's false. You shouldn't repeat that. So there's a strong precedent there in how humans, as peers in a world, in a network, repeat or don't repeat information, and in aggregate are able to make decisions about what information spreads in the network around them. And so how does that work in a technical context with IPFS? This is not yet implemented, but this is how we're thinking about approaching this, is that people should be talking to each other as individuals and as groups that are interacting with each other, where anyone can identify the data that they think should be either allowed on the network and encouraged on a network, or data that they think should be blocked on the network and not repeated. And by expressing that as data sets or databases of block lists or allow lists, which a lot of people want to call black lists and white lists, by creating those databases, then any individual on the network can subscribe to those data sets and apply them voluntarily on their machines. And so examples of those block lists, it might be a government saying that within our jurisdiction, you are required to apply this block list. It might be a community saying that as a community on our network, we don't approve of this content, we don't want it on our networks. Or it might be an individual just saying, I don't want to have this content on my machine. So these decisions should be made where groups and individuals can be making those decisions interactively and talking to each other about what should be in those lists. The example here of how this would work is you can intuitively think about how antivirus software works, where when I'm running antivirus software, it's occasionally downloading a new database of information that's been identified as harmful, and then you're voluntarily purging that from your machine. And you can choose which databases you're going to pull down in order to apply on your machine and purge. Now, think about the alternative here, where the alternative is in a centralized context, you have a few centralized parties that are making the decisions about what content is allowed or not allowed for everyone. And the main means, and they have a profit motive fundamentally driving their decisions about what is allowed or not allowed. And our main means of putting pressure on them is solely through governments. We have very, very little voice other than through a government to really put pressure on those organizations around what content they do or don't allow. And so in this context where we're in a peer-to-peer context and we are possessing the data that we hold and making decisions about what data we will possess and participate in distributing, it immediately invokes the question, or eventually invokes the question of stewardship. These questions of what data should be stored, who should store it, and how do we ensure that everyone who should have access does have access? How do we ensure that people are able to discover and find the content that they're looking for? And how do we ensure that the information is preserved for the long term? Let's look at how a centralized system or a centralized approach undermines those activities, how it makes stewardship more difficult. Because in a centralized system, every location where you're using a location addressed protocol, every location where you're storing the data is competing to be the location where you retrieve the data. If you make more copies of that information, even though they're identical, and even if your intention is to increase availability, you're actually creating a new information resource that's competing to be the location where the content exists. And now you end up with this separation of the system into competing entities. Think of the alternative. In a decentralized context, when you're using a peer-to-peer protocol, it's easy to replicate data. Once you've replicated it, if it's content addressed, it's easy to validate that replicas truly are identical replicas of each other. And then having done that, the more copies you have on the network, the more available the data becomes. So redundancy is cooperative and reinforces availability rather than being competitive in nature. And so one of the most important things here is that allows for us to tackle this problem of identifying what content is at risk, what content should be replicated, what content should be held more redundantly, and why should it be held? Who is it valuable to? Why is it valuable? And we can make those decisions at web scale. So there's no one organization or small set of organizations who are deciding what is the content that's valuable, why is it valuable, and how should it be replicated. Instead, anyone can make those decisions as individuals or as groups. So those are the two things about governing the content on the protocol that people ask about the most. Then in terms of governing the protocols and code bases and open source community, I want to speak a bit about how we are working to provide sustainable or achieve sustainable, transparent, community-driven governance of these code bases. So this is a place where we have a lot of strong reference points to look at, both reference points as examples of things we can aspire to repeat and examples of pitfalls that we can try to avoid. So we can look at standards bodies like IEEE, IETF, and W3C. We can also look at how programming languages like Python and Rust are managed and governed. And then also we have this rich set of reference points of open source communities and best practices that have arisen in the open source world around how code bases and communities are convened, how they're governed, and how decisions are made. So currently what we're doing in that space is that David Dias has led great efforts around designing working groups and having a process for working groups to form and maintain themselves. We're forming an RFC process, and then we're poised to do a bunch of work that Michael Rogers is going to be leading around community operations. So this is about operationalizing and making repeatable a lot of those best practices that we've seen happen in the open source world around us. So watch for a lot more in that, on all of three of these things in the coming months. And then the final section, the questions that some people ask about, but everyone should be asking about, especially around security, privacy and surveillance, and equity. So in terms of security, I want to remind everyone that when we moved from the PC context of the cycles of the technology world, security was in a pretty bad place. Maintaining security in that decentralized context of everyone runs their own personal computer was really hard, and it was really inconvenient. And getting away from that inconvenience was one of the things that drove people into the cloud, where Bruce Schneier, the security researcher, wrote a series of essays a couple years ago where he called this feudal security, where you're relying on the landholders and the knights of the realm to provide professionalized protection for you, but their interests are not necessarily aligned with your own. And that's what we're relying on right now in the cloud. That's what we're doing when we've centralized the data and we're relying on we get the benefits of professionalized security, but we get a misalignment of interests. So as we move towards a decentralized context, remember that that also means we're taking on the headaches of decentralized security. It is harder. And getting specific about peer-to-peer, peer-to-peer nodes are really chatty. They're opening up arbitrary processes that are connecting with each other. We're challenging the single origin assumptions in web browsers. There are a lot of things where we're shaking up security. And so this is a rocky space that has some benefits, but it also has some costs. And then I want to point to, we have an option of what to move to that is not just a re-centralization in order to achieve security. And that's where we need to look at distributed computing, of having reproducible builds, having verifiable computing, being able to have capabilities-based systems. That's how we can have good security, people protecting themselves at scale as a network without having to re-centralize our communications. Then in terms of privacy and surveillance, peer-to-peer nodes are really noisy. Due to the nature of the way a peer-to-peer network operates by default, it's very easy to surveil that network. It's very easy to gather information about activities on that network. And so now there's a lot of technical fixes that we can and are applying around creating writer privacy or allowing people to anonymously publish information, creating reader privacy so you can read or consume information without the peers around you knowing what you're consuming, allowing people to form private networks where they control which machines they'll communicate with, and allowing people to encrypt their data and use capabilities-based approaches to control when and how data can be accessed. But the thing to remember is that those are all technical fixes, when operational security is ultimately a behavioral thing. That in order to actually achieve operational security, in order to actually address concerns around surveillance and privacy, you need education, you need to change cultural norms around how people behave and communicate, and you also need really great user experience. You need great product design in order to make these things easy and intuitive and automatic. Now the cautionary tale here is email. That email has always been a decentralized protocol. It's always been possible to, or not always, but almost for a very, very long time, it's been possible to have end-to-end encryption with email. Yet, almost nobody uses end-to-end encryption with their email, and the vast majority of people are using centralized systems, like Gmail, to pass their emails around unencrypted. So the problem is not just technical, the problem is behavioral. And so we need to keep our eyes on that in governing these protocols. And then the final thing is to remember that decentralization doesn't guarantee equity. Just because we're using decentralized protocols does not guarantee that everyone's going to have a voice and everyone's going to get to be an acknowledged peer on the web. If we want that ideal to be achieved of a genuinely peer-to-peer global network where everyone gets to be a peer, we have to work really hard to ensure that we design these technologies and protocols to actually provide equity. And so we need to think about what are the ways that people can be marginalized. There are economic, cultural, geographic, and other ways. So for example, if you don't have access to the technology, then you're not getting the powers that are provided by that technology. So what are the ways that someone could be prevented from even having access? If you don't have the knowledge of how to use the technology, or you don't understand how it works, then you're missing out on the benefits. If you don't speak the language that the documentation is written in, or if you don't speak a language that would allow you to ask questions or express your needs clearly, then you become marginalized. Geography, so if you're in a geographic location that it makes it really inconvenient time-wise to participate in a governing decision, then you get excluded. Or in terms of connectivity, these peer-to-peer protocols are designed to be, well, a lot of them, like IPFS, are designed to be offline first, but if we're designing these offline first technologies with the idea that they're going to be useful for people who have limited connectivity or intermittent connectivity, but we make all of our decisions about how to design and build those technologies using centralized tools and centralized patterns where you need a connection, a very fast, steady connection to the backbone in order to participate in the governance, then we're basically governing on behalf of the people who we're building the technology for, rather than allowing them to have a voice. So we need to think about those things and think about how we include those voices, how we include those concerns in our designs and our governance decisions. So thank you.